Hello student, welcome to all of you in the next physics lecture. This is the video number 28. We are to see here the chapter number 3, kinetic theory of gases and radiation. And in this next session, myself, Mr. Rajesh Lagat, physics teacher. Now we are to see here the next point is the perfectly black body, also known as a Fairy's, the name of the scientist, Fairy's black body. Previous lecture we have to see here the coefficient of absorption, coefficient of reflection, and the coefficient of transmission, and sum of these all these coefficient is always equal to unity. We have to see here. Now we have to consider here there are some substances, the substances through which the heat radiation can pass, which is known as a diathermal substances. And for that, this example of these diathermal substances are glass, quartz, sodium chloride, hydrogen, oxygen, dry air, etc. These substances are nothing but the diathermal substances, the substances through which the heat radiation can pass, which is called as the diathermal substances. On the other hand, there are another substances known as the athermal substances, the substances which are the large opaque through the thermal radiation, and these substances do not transmit the heat radiation incident on them, which are known as the thermal substances. Examples of these thermal substances are water, wood, iron, copper, moist air, benzene, etc. These are the examples of diathermal substances. Now we have to see here the next point, that is a perfectly black body. Explain the term perfectly black body with the suitable diagram. Then first we have to draw here the diagram for this perfectly black body, also known as a Fairy's perfectly black body. In that diagram we have to consider here the two surfaces. This is nothing but a double walled hollow sphere. This is the first wall, this is the second wall, therefore it is known as a double walled hollow sphere. Now it has a small aperture as shown in this figure, and from this the incident radiation enter through this small aperture and incident on this conical projection. This is nothing but a conical projection. Because of that, there should be the multiple reflection from this conical projection. Then in these two hollow walled sphere, there are the space is known as evacuated space in between this double walled sphere. The inner surface of this hollow walled sphere, which is coated by the lamp black. You know that the lamp black is an example which can be absorbed the more than 98% of the radiant heat, and this is known as a lamp black. And this lamp black will be the coated inside the surface of this double walled hollow sphere, inner surface which can be coated by this lamp black, and outer surface of this double walled hollow sphere, which is coated by the silver polished surface, which is as shown in figure. This is the outer surface, this is the inner surface coated by the lamp black, and this is the incident radiation. And this arrow should be is nothing but there are the multiple reflection, and in each reflection this inner surface which is coated by the lamp black, which can be the absorbs the more than 98% of the radiant heat in each reflection, and last one all the radiant heat incident upon it, which can be the absorbed by this lamp black, and this is acts as a perfectly black body. Now we can see in details this perfectly black body. The coefficient of, we know that the coefficient of absorption of a body, which can be depends upon the nature of its surface, and also we know that the black surfaces are found to be a good absorber of heat. We know that these black surfaces are the good absorber of the heat. For example, the lamp black. This lamp black is nothing but which absorbs the more than 98% of the radiant heat incident upon it. Lamp black is acts as a perfectly black body because the which can be absorbs the more than 98% of the radiant heat incident upon it. So that we have to take here the lamp black, which can be coated by the inner surface of this double walled hollow sphere. A body which can be absorbs all the radiant heat incident upon it, which is called as a perfectly black body. We have to define this perfectly black body. What is meant by the perfectly black body? Then a body which can be absorbs all the radiant heat incident upon it. Body which can be absorbs all the radiant heat incident upon it, which is called as a perfectly black body. And the coefficient of absorption of the perfectly black body is equal to 1 because all the radiant heat absorbed and there is no part of the body which can be the reflected or the transmitted, so that the coefficient of absorption of perfectly black body is equal to 1, and while the coefficient of reflection and transmission is equal to 0 because all the radiant heat absorbed by the body. This is the perfectly black body, and so that there is no reflection and no transmission, and so that this coefficient of reflection and transmission is equal to 0, and the coefficient of absorption of the perfectly black body, which is always equivalent to 1. Okay, now we have to see the explanation of this perfectly black body, how that double wall hollow sphere can be acts as a perfectly black body. This perfectly black body, which is the consist of a double walled hollow sphere, which is shown in figure. There are the two walled, but they are the hollow. Therefore, a perfectly black body, which is consist of the double walled hollow sphere, having a small aperture, as shown in figure. This is a small aperture, and the inner surface of the sphere, which can be coated by the lamp black, which is also shown in figure. Inner surface of the sphere is double walled hollow sphere, which is coated by the lamp black, and it has a conical projection opposite to this aperture. This is the conical projection for the multiple reflection. When this radiant heat incident, then which can be the incident on initially this conical projection, and which can be reflected from this conical projection in such a way that incident radiation enter through this small aperture opposite to this conical projection, and when this incident on this conical projection, which undergoes a multiple reflection. First reflection is this, second one, third one, fourth one. In this way, there are this sphere suffers the multiple reflection. During this reflection, each reflection, this inner surface of the sphere, which is coated by the lamp black, which can be absorbs the more than 98% of the radiant heat incident upon it. When the incident here absorbs the 98% of radiant heat, incident here absorbs the radiant 98% of the radiant heat here. In this way, within a few minutes, all the radiant heat incident upon it, which can be absorbs the inner surface of the sphere during this multiple reflection, and so that all the radiant heat incident upon it, which can be absorbed, so that this double walled hollow sphere, which acts as a perfectly black body. In this way, this double walled hollow sphere, which can be absorbs all the radiant heat incident upon it in multiple reflection. In each reflection, that inner surface, which can be absorbed all the radiant heat. Another reflection, which can be absorbs all the radiant heat incident upon it. In this way, within a few minutes, all the radiant heat incident upon it, which can be absorbed by the sphere, and so that this double walled hollow sphere, which acts as a perfectly black body, also known as a Ferris black body. Okay, if you have to understand better, okay, stop here. Thank you.